It's not really again. No, it has nothing to do.
So much free time.
Nick, are you going to slow talk every one of the presentations as they walk up?
Yes. Kyle Carreto. All right, yeah.
Clap, clap. Please clap.
Do not disturb. Yes.
Cool. All right, so pretty much I'm going to talk about Python real quick. Who am I? I'm the same guy I was last week, but I feel like I wanted to add some more stuff to this. You'll get the reference at the end of the presentation if we make it there. So I've been procrastinating.
You don't have to lean in.
I started writing this today. And overall, I think it's going to be a good presentation. So what are we about to talk about? I'm about to cover most of Python, or I'm going to try. It's going to be kind of fast, kind of a speed run, but feel free, if you have questions, to interrupt me. We can stop and talk about anything you're going to have questions about, because I guarantee probably everyone in this room is going to have questions. And it's going to be fun. We're going to learn together, and later on, check the stream for a video if you want to go back and reference some of the stuff that's said here. Because we're definitely not going to have time to go over everything, but I want to kind of lightly touch on just about everything. And some stuff that people probably haven't heard about before. So, we're going to start really basic. We're going to start with hello world, right? So in Python, you've got functions, which are defined by the def keyword. And Python is actually an interpreter, right? So it runs in order, top to bottom, and interprets each line of code. We have print, which is a built-in, and I think most people are in CS1 and completed the first week, so most people understand what's going on here, I think. We have PEP, which is a standards organization. PEP 8 would be the code style standards that you'd use. And overall, this is a pretty easy script. So we have a bunch of built-ins, which is where print comes from. This is a table of all of them. I think that these are the most common, probably. I use a bunch of them on just regularly. They come in a lot handy, especially is subclass and open and stuff like that for I/O. So now we can talk about typing. This is something that's kind of new to Python 3. 7 has type-ins. So Python's dynamically typed, which means variables can kind of change types at runtime. There's a bunch of basic types that are pretty common to all the other languages, so we don't have to go too in-depth on that. There's dictionaries, ints, strings, bools. There's objects as well. Everything's actually an object, which is what we're all going to learn pretty soon. Speaking of type-ins, use them, please. Basically what happens is typing is a new library that Python's had for a little while, since Python 3. It gives you all these generic types that you can use to wrap different complex combinations of types. So for instance, I have a type alias right here of JSON, which is a dict of strings to any. And I can basically set a parameters type by using the colon here and then just specifying what type it is. And I can also say what return type this function is going to have. What's really cool is this new thing that's coming out called Pyre, which is a Python type checker. It can infer types both statically and dynamically, when you run your code. And it's trying to help improve code integrity overall in Python, while still making it pretty easy to use and very readable. So, next, we're going to touch on string formatting really quickly. Python 3.7, or I guess Python 3 in general, introduced this little F character that you can precede strings with. That pretty much gives you access to use any variables in the current scope in your string formatting, and it'll automatically convert them to a string for you, which is super useful. And I think if you guys use Python 3.7 and CS1, you should use this. And you can also perform kind of some minor operations. I can just add 1 to this number here, and it prints out 6. So I think that's pretty useful and cool, and that's just a little nice tidbit to know. Basic flow things now. So we've got the for loop, right, which just iterates over a bunch of things, so you don't have to repeat yourself a bunch of times. Range is just another built-in that gives you a list of a bunch of things up to 10, so it'd be a list of 0 through 10. So this is basically just print out 0 to 10. In is a keyword that lets you iterate over a set in a for loop. You can also use it to check if an element is in a list. There's a couple other uses for it. You also have recursion, which you guys probably find out that basically it's a function that just calls itself. And the reason it doesn't infinitely call itself is there's this thing called a base case, which prevents the function from looping infinitely. So the next thing we're going to talk about is exceptions, and we're almost through the core of Python at this point. We're getting there. An exception is some kind of unexpected action occurred, right? So if you try and access a dictionary and the key is not there, or if you try and call a function that doesn't exist, right? It'll raise some kind of like built-in error. You can actually define your own exceptions for programs, which is the preferred way in Python. A lot of other languages have a lot of overhead when exceptions are raised, but Python's really good at just having exceptions be handled in a decent amount of time. So it's actually the preferred way instead of trying to check all of your input, just throw exceptions. Try and accept are two keywords you can use to handle exceptions. So try just starts like a little block that you can use. And then any code in there that throws an exception will raise up until the try block, right? And then it'll be accepted by whatever accept statement you have here. And you get a multiple accept statements per try block. So what happens in this code is when we run exception example, it'll raise this exception. However, because we accept the exception, it'll just print this other code and we're all set. So now we're going to go into some more like basic stuff, but hopefully we'll speed up a little bit. We've got main. So basically how Python defines modules, right? When you first run your Python code, you run like whatever module you're running is going to have the __ main __ definition. And that's why you see like this very common code at the bottom here. If __ name __ is main, then run the function. That prevents code from being running when it's imported. Because like I said earlier, Python's an interpreted language, so Python literally just reads and executes every line. So if you have code that's laying like out in the top level of your module without like it being in functions and stuff, it's going to run as soon as Python imports that module. And we'll talk about importing in a second. But Python sets a lot of special variables with a double underscore, and we're going to get into some more of those in a little bit. So why is importing good? Importing is good because you don't want to have to rewrite the wheel every time. It's good to be able to import like JSON and use JSON.dumps to get a string formatted JSON blob and stuff like that. In fact, this is like one of the things you're going to do a lot of the time. Is just when you're like working on a security project or whatever, you're probably not going to write a lot of code for it. So you're just going to be taking all these awesome libraries that people have already wrote for you and just kind of plugging them all together and make something cool. Now we can talk about packages, which is pretty much how those libraries work. So Python defines a package as basically any directory with an __ init file in it. I think I missed that in the screenshot, but basically if you put an __ init file in the directory, Python will interpret that directory as a package, and they'll let you export different things from it, which is actually how like a lot of the libraries that you'll use work. Also, the __ init file will be run when it's imported, which is cool because you can like use that to do different kind of logic based on how you want the package to be imported. Package management, so we have to talk about pip now. So pip is probably the most useful component of Python, I think, and just the most useful tool. You're going to use this to pretty much install all of the different dependencies for your libraries and stuff like that. It's pretty standardized. I don't know if there's any other package management tools. I think pip is by far the most common. But basically, all the libraries that you're going to find throughout your time here, you're going to be able to install using pip. And you can also save all the dependencies that you have using like this command called pip freeze, which will take all of the dependencies that you have installed right now and output them to like a text file for you. And then later on, when you install like other people's projects and you want to work on them, you can use the requirements.txt file to look at that stuff. You can also build your own pip package. You just add a setup.py file to your root directory of your project. And basically all it does is it just kind of defines some basic information about your project. And then that allows pip to build it and install it for you. It's actually really easy. I was surprised. And what's really cool is if you don't like want to upload your package to pip, you can actually host it on Git. So I basically uploaded my package to GitHub, and then you can actually check out my workplace for how you can do that. I have like a little workplace note that I wrote up, so check that out. Anyways, some useful libraries. There's probably too many to mention, and honestly, that's very like specific to whatever projects you guys are going to be working on. So I feel like every time you start a project, you're always looking to see if someone's actually written this before. Like, do I have to do this myself, or can I just kind of use what someone else has already had? And one of the easiest ways to find libraries is this awesome Python repo. It's a giant list of awesome repositories that you can use that basically will do most of the things that you'll actually have to do in a lot of your projects, and they'll save you a lot of time. There's awesome lists for just about every language, so if you're looking for things that are not just Python, overall, like you'll be able to use awesome lists to find a lot of good resources, so check that out. Okay, so now we can get into like classes and objects and stuff. Classes are basically just like blueprints for instances, and you can have as many instances of an object as you want. So basically, if I had like Adler as a person and his height's like 5'10", and I have Mike who's a person and his height's like 5'4", I can have two different instances of the same object, and that lets me do like a lot of different things. And I guess like the use case of that will make a lot more sense as we go. So we can just kind of keep going. Now what you did notice in the last slide is when I wanted to make the object, I have to like set the field afterwards. And that's kind of annoying, right? Especially because it's like an initialization thing. So you can define like this init function on each class that'll basically perform all of the initialization when you're instantiating the class. And so we just take one parameter height and we set it to self. Self is basically passed to the instance as a reference to itself, right? So basically if I have Adler right here, that's an instance of person. Self on any function in person, or in Adler, I guess, right, is going to refer to that instance of the object. Does that make sense to everybody so far? And basically this just makes the code look a little bit cleaner, and it's useful in a lot of different ways. Now we get a whole slide for dir, and we're going to talk about a lot of the other Python kind of built-in black magic things. But basically what dir does is it just shows you all of the attributes that are available on an object. So if we just had like an example class example, we can see that hello is actually registered on there, as well as all the methods, so yay is on there. But we also have all of these underscore underscore prefix things, which are all the built-ins from Python that it actually uses to interpret all the code here, which is super interesting, and we're going to look into that in a little bit. So we're getting there. Basically, there's another thing called star args and keyword args. Basically, args is a placeholder for positional arguments. So for instance, if I have some function, another func, that takes a parameter, and I have example function that takes an example parameter, I can call example with the first parameter, which will be called example parameter. And the second, like all of the other positional arguments that are used are passed as star args, right, which comes out as a list. So basically, I printed out the example for you. And what you can see is in example, like the function example, star args represents a tuple actually of all of the positional parameters, and you actually have a dict of keyword args, which is cool. If you want to call a function using the star args and star keyword args that you've been passed, you just use the little star asterisk operator here to pass the star args, and you use two of them for keyword args. Everyone understand how those work so far? So far so good, because it's going to get a little bit more complex, so I just want to make sure everyone has a very good foundation of what's going on. Cool. So now we're going to talk about inheritance real quick. Basically, it's how you can kind of avoid code reusage. You have like a base class person, which has height and some kind of constructor. And what you can do is you can have other like classes here that basically define more specific things, right? So you kind of abstract and then you kind of specify downwards, so that way you can reuse code in different ways. Right? Basically, the way that this is working is we define our own init function on the Mica class, and we just call the constructor using super. So super is an awesome function in Python 3, I think. Well, I think it came out in 2.7 as well, but the usage of it kind of shifted a little bit better in Python 3. But basically what it does is it lets you access the parent class of whatever class you're in, right? So in Mica, it's a subclass of person, so I can access the parent class, which is person. And that lets me call the initialization for person in case there's something that's going on there, which in this case it's setting the height, so it's pretty useful. Also, this is another reason star args and keyword args are super useful. If you have like an unknown amount of parameters that you're going to be sending to a function, right? Like you want to keep things kind of generic, you can actually just accept star args and star keyword args and then just pass it to the constructor, which is kind of a useful way to be able to do that. Alright, so now we're going to talk about static class methods, or static methods and class methods. A lot of people really don't know what the difference is between these two. And to be honest, it's not a huge difference. Basically, both of them can be used without an instance. So they're defined on the actual class type. They're not defined on any of the instances. When you have an instance of an object, you can modify it, and it's not going to modify all of the other instances. When you have a class, right, and you modify height. So if I did capital P person.height, it would modify the height for all of the other instances of the object. But the difference between static and class methods is that static methods require no additional context about what class they're in, whereas class methods require that you pass in the type of the class that it belongs to, right? So for instance, in this example, not static, which is a class method, takes two parameters as opposed to one. And the first parameter has to be CLS, just like in other cases, as we mentioned earlier. We have self, right? So that's how instances are passing their representation of themselves. So what happens is when you pass like person.notStatic, it sends the type person to this function, and that way you can access it if you need to. Cool. So moving on, we have properties. Basically, properties just let you have getters and setters for different things. I guess the most common use case for it is probably that you can just kind of run some kind of short code to determine what a field's value should be, and then just return that value. What's really cool about it is you just access it as you would any other field, right? So you basically just do Micah.shouldPresent as true, which makes a lot of sense. And it kind of lets you calculate something at runtime versus having to keep setting it, which is the main use case of properties, I think. Cool. Now we're going on some really cool stuff. I'm going to try and go a little bit slower through this part. This is probably, I think, where people are going to start getting a little thrown off, because this is starting to get a little bit more advanced. So for instance, like abstract classes, this is like a CS2 thing, but in Python it's a little bit weird. Because basically you have to import a library to be able to do it, and I feel like a lot of people don't have a good understanding of how this works, which is actually what I'd like to focus a lot on, is basically when you define an abstract class in Python, you have to import this other library that wraps some stuff for you using some magic stuff, and basically it creates an abstract class. An abstract class, I guess I should define that first, is basically a class that you can't instantiate, right? The whole goal is just for it to be a template for other classes to use, and maybe add some functions, maybe add some fields on there, right? But the whole goal is not to instantiate that class itself, but for people to subclass it, and then you can force those subclasses to implement different functions, right? So if you want a bunch of like modules to conform to a certain interface, you'd use an abstract class to enforce that. Now we can talk about nested functions in classes real quick, and we'll get to the abstract class stuff later, a little bit more in the internals of how that works. So just bear with me while we get through this stuff. So just real quick, you can nest functions in classes. So basically I can have a class within a class, or I can have a function within a function. And the cool thing about the function within a function thing, this is kind of a preface to everything that we're about to talk about, or a decent bit of what we're about to talk about, is how can I upper return this lower without calling it, right? And actually what's going to happen is we just have a function pointer. So instead of calling lower, we just return the pointer to that function, which is basically just an object, right? Because pretty much everything in Python is an object, and we're all going to see that very shortly. But because lower is not called, we just return the object of the function, which lets us call it later, right? So if we wanted to return the function pointer, we can then call that function pointer at any time. We can pass it around to different things. It kind of lets us be a little bit more abstract with how we're trying to call things. And this is how we do decorators in Python. So those funny little @ symbols you've been seeing like for the past couple minutes here, like in static method, class method, all those are really doing is decorating. Python kind of supports this character to just, basically what it does is it passes the function below it as a parameter to your decorating function, right? So if I have my decorator is my decorator, right? It takes a parameter of a function, and then what happens is this little @wraps thing just comes from func tools. You don't have to worry about it too much. It just kind of sets some stuff up to be nice when you're inspecting different things. Check it out if you want though. And then I have a nested function here though. This is the important part. I have a nested function that actually performs whatever actions I want, right? And it has a pointer to function. So basically what I did in this decorator is I basically have a decorator that wraps whatever function I'm trying to call in a try and except block. So that way I can just accept any exceptions, right? This is really useful for not duplicating code and just having a bunch of functions that have similar properties, right? So it's kind of like, imagine inserting whatever function I wrap into this little block right here. All right, so now we're going to talk about like the really cool stuff that I was trying to focus on a little bit more. So you can actually have class decorators, right? Which is another thing that most people probably don't do. You probably haven't heard much about. But basically what you can do is instead of using a function to decorate like we were using earlier, it gets past the function handle, you can actually use a whole class to do that. And why that's useful is that it gives you a lot more control over like the state machine of what's going on in any function's execution. And it gives you a lot more like ability to like just keep state on like different things, and if you want to like decorate things differently. So for instance, if a function runs once, you want the decorator to act one way, but then it's been run, so you want to act a different way. A class decorator is a really good way to do that. So basically just have the constructor or the init function of the class handle the function parameter, and that's just going to be your pointer. And then it can call it, it can do whatever you want. And you also define this underscore call thing, right? And this is another interesting part of Python, is that most of everything that happens in Python you can just see in front of you. It's just kind of hidden at first. But basically what this call thing is that it's just a function that, or it's, I guess the function that's called on the function object, if that makes sense, right? So remember, back up for a second. We have functions, which we've learned are objects, right? And we're going to return pointers to them. Okay, on the function object, we have the call function defined. And anytime you call a function, this is the actual code that's run. So what call actually does at most function objects, because they inherit from the base function object, is it just runs whatever code you define in your function. But I think that's really interesting in how Python overall works. And it's going to come in handy in a little bit when we start talking about the metaclass stuff. So real quick, you can also pass parameters to decorators. So if you want to change like some of the functionality of decorators or give them additional functionality per function, what you can do is just define a decorator around your decorator for some reason. So you just have like triply nested functions, and then the first decorator just takes all of the arguments. And it kind of makes sense if you think about it, right? Because what happens here is because we're calling the decorator here, we have like little parentheses, we passed all the arguments there. What happens then is it comes up to the first decorator, and it takes all of the arguments. It accepts all of them. You can do whatever you want for arguments, and it'll take all of them here. And then it's available to all of the other like underlying nested functions because of how Python scoping works, right? You can always see like any nested functions can see the scope of the current like function stack, at least in this case. So then what we do is we just have our normal decorator function that we had earlier, and we're just going to print out the argument that we were passed and then call the function and return the result of it. So basically we have this inner function here that actually performs the work. That's the function code that we're trying to call. We have the outer decorator, which basically just returns the function pointer. And then we have the outer level, which takes all of the arguments, sets things up, and just returns the function pointer to the decorator. Cool. Does everyone understand how that works? That can be like really confusing, and I think it's kind of hard to like show on a slide. It's more like when you're using it, it makes a little bit more sense, and I Google it literally every time. But if there's any questions, just feel free to let me know. So now we're going to talk about factories. Factories are basically just a function that returns a class. You can have it return either an instance or a new type. We'll talk about defining new types on the fly in a second. But basically what you can do is you can use the type built-in keyword to define new types in the sense of like, instead of having to write out like in your code, class and class and define some fields on it, what you can do with the type keyword, I think that's next. No, okay, so the type keyword basically you pass it some arguments, and what it does is it takes the name of the class that you're trying to define, any base classes that you want to inherit from, and a dictionary which maps any fields and methods onto the type. And that way you can actually instantiate new types that way, which comes in handy in a lot of different situations, so it's just good to know about. Now, what's really cool, I learned about this a couple weeks ago actually, is I think they came out with a new init subclass function. It's another one of those hidden Python functions that you can find. What's really interesting about this one is that anytime a parent class is subclassed, right? Anytime a parent class is subclassed, this function is called on the parent, right? So basically, I think the example I have here is a pretty good way of looking at it. I have some parent class that defines this function, and it's passed the type of the class that's subclassing it, right? And then, just to show like what that looks like, if I subclass parent with a child, right? What happens is this init subclass function is run during the definition of a child, and it registers the child's name, so a child, to its type in this dictionary on parent. That's really good for keeping track of all of the things that have subclassed your class, which is like super big deal. If you're lost right now, just remember this, because this is super cool. So come back to this like some other point when you're working on projects, you'll understand like why this is so useful. And now we can just talk about metaclasses, which is like, I guess how I'm going to end the talk for the most part. We're going to have a couple slides on this, and it's just another thing that I just learned a couple weeks ago. That is, this kind of just blew my mind on how this works. So I'm going to slow down. We're just going to take it slow. And if anyone has questions about metaclasses, that's cool, because it's kind of what I want to talk about. So, instead of basically inheriting from object, metaclasses are inheriting from type, right? And basically what they do, like why they're important, is you can define a metaclass as a blueprint for a class, in the same way that classes are blueprints for instances. So basically what you can do with this is take a class that's being defined, and if you set the metaclass for it, it can alter the definition without you having to write any additional code. So for instance, ABC, right, the abstract base classes in Python, how it actually enforces classes to be abstract is you set the metaclass way earlier on to be the abstract base metaclass, right? What this does, this metaclass does, is it just wraps all of the functions that are decorated with the abstract property, abstract static method, abstract class method, all that stuff, right? It finds all of them, And it literally wraps them to make sure that they're not that they're defined. Otherwise, it just raises an error. That's how the abstract library works. It's not very large. You can go look at it. ABC Python is a really cool library to understand metaclasses and how it works, and how it actually affects everything that you're doing a lot of the time in Python. I found this out, and I was like, how can I just mess with this a little bit? Because I just wanted to play around and see what was going on. So I'm going to show you a little bit of what I did. But first, we got to talk about some of the other properties of metaclasses and how they actually work, right? So we have three main functions that we want to override with this metaclass to basically alter the definition of classes at runtime. The first one is new, which is a hook when the class definition allocates memory for a new instance of for the class, right? So when you're trying to define the class, you have to allocate memory for that type. When that's happening, new is called, and you're able to just modify whatever you want. And it's very similar, so just imagine the same thing, but instead of allocating the memory for it, it's just being initialized. Both of them are the same in the sense that you get past these four parameters that you have to work with. The first one is the actual class of the type that's being defined, right? So if I was, defining example, right? As Python interprets this line, right? It executes this line and it goes to look at the meta class, right? And it's I have to allocate new memory for this type. And now it hits the new hook, okay? Meta would be example in this case. Does that make sense? It's this type that's being defined. We have name, which is the name of the type being defined. Bases, which is a tuple of base classes that this inherits from, right? So if example came from different parent classes, we'd be able to see those here. And I'll show you an example in a second, which makes sense why we have that as the case, because it gets really confusing once you start messing with all the base class stuff. And lastly, we have a dict. Basically, the dictionary here represents all of the, fields and methods that are being defined on the new class type, right? And you can modify that however you want. So in this case, I just have an example meta class that takes a new field and it sets it on any classes that use it as its meta class. So basically, example in this case, even though it has nothing defined on it, since we defined the meta class for it, it has this new field thing defined on it, and we can use that for any other class that we want. That's a very contrived and basic example, but it kind of gets the point across that basically whatever I'm defining here is not actually what's happening, because Python's executing this line of code, and then it's using this as a template to build that definition. And also inheritance works, which is pretty cool. So for instance, in this last slide, we defined something that used the meta class example meta, and in this next slide, we can have child, right, which just inherits from example. But we also, in the example meta, it's still affected, right? So in that way, we still have the new field defined on the child class, even though we didn't actually explicitly set the meta class. So now we're going to actually look at some code and see why this is actually useful, because I've been talking for 20 minutes and people are like, why am I listening to this? So I've been working on a project lately that is trying to wrap Mongo Engine. If you guys don't know what that is, basically Mongo Engine is an object, document mapper or mapping. Basically, it just lets you use Python classes to access a Mongo Engine or a MongoDB database, and that lets you store data persistently, and that's how a lot of web stuff works. So basically, what I've been doing recently, besides this demo code that I've been working on for this presentation, is a library to wrap that. And when I actually found out, the reason I actually came across metaclasses is because Mongo Engine defines them. And what's really interesting about metaclasses in this sense is that you can't overwrite some of the things that metaclasses are doing without actually making a metaclass yourself, because it's happening at the definition time, right? So Mongo Engine, when you define a document, right, that inherits from the Mongo Engine base metaclass. And what that's doing is it takes all the fields that are on your document. I'm about to show you, actually. Let me pull up an example while I'm talking. But basically, it pulls up, it takes all of the fields that are defined on your class and actually changes them. It just takes what you have as basically arguments, and then it makes a document that looks nothing like the definition, right? It looks nothing like the definition. It has a bunch of methods that are nothing like the definition, and you can't change that, right? After you inherit from whatever document class, you cannot change any of the things that it has done to the class definition without writing your own meta class to inherit from. So, I think, what do I do this in? Yeah, all right, so we can look at the meta class real quick. So basically what I was trying to do is So I was trying to wrap the Mongo engine document to basically allow me to manipulate certain fields and kind of put like more easy to use default functions on them, which lets you kind of create APIs a lot faster, right? So I hooked the new function here, and some of the code might not make a lot of sense, but I'll kind of try to explain it as we go. So basically what I do first is I look at all of the classes that the object is inheriting from, right? So whatever class is implementing my meta class, I look at all of the parents of that thing. And I basically check it for a single attribute, fields. Like, if any of the parents have any fields on, like, defined on them, then I want to pretty much take all of those fields that they have and just put them onto the new object, kind of in a different place, right? Which is pretty much what I'm doing in a sense. I'm taking this document dictionary and I'm updating it with all the new fields, and I'm just kind of prefacing it with an underscore. Next, I basically just take, if there's a meta thing that's been passed to me, using like the name, I just set it here, and I override it with the field called underscore meta overrides. If I did this, if I was like del underscore doc meta overrides like this. So if I do that, basically what's going to happen now is it's going to take meta overrides. You'll define that on your class, right? So that'll be in your class definition, you'll see it. But if I delete it here, it's not going to end up on the actual instance, if that makes sense. Like when your class is actually defined at runtime, it's not going to have that property, which is like the big problem that I was running into with Mongo Engine and why things are like just really weird. Also, I mean, since you're defining the class, you can also define all the methods on the class. So I'm like, you know, fuck it, I'll just add a bunch of different shit to it to make it easier for me. So I was like, here's a JSON method. I guess we'll just like put some other stuff on here. Here's like a little document method to point the new type that I'm building. I think I have a good example here. Yeah. So right here, I'm building a new type for the document subclass that I'm doing. So Mongo Engine makes you subclass all like documents for any specific object that you're trying to access in the database. And so the way I did that, instead of actually explicitly defining documents, is I just built a new type and was like, hey, just inherit from this, right? And now I can kind of do that on the fly, if that makes sense. So I just kind of generate a name based on whatever class I'm defining, and now I can automatically spin up different like instances of this class, if that makes sense, or types of this class. And then I just define some other fields on it. And what this ends up looking like, I guess, right? Like the end result of this is now, let's go here. This is really all I need to define like an object in the database. So I just define this subclass called fields, and I can put whatever fields from Mongo Engine that I've also wrapped in a different way on here, and then I can automatically have like an API to access and update those fields and objects in general. So that's what I've been using for recently. I thought it was super cool and mind-blowing because it kind of showed me a lot about how Python actually works under the hood. And it was kind of a journey in exploring how like the Python interpreter is actually interacting with a lot of the code that you're writing, and how like, I guess, when certain bugs happen, like it's not necessarily your fault, it's just something you couldn't see in general. It's a really good thing to know about. So I thought that was pretty crazy. But that pretty much concludes what I was going to talk about today. So are there any questions on anything that I just talked about? I went from literally like, what is a Python function, all the way to like this thing that I've never heard about in a very short amount of time. So I hopefully that was useful to some people. I just tried to touch on things overall and just give people like some stuff to look at, right? Like a lot of different things in this presentation could have been a presentation on its own. There's just a lot of cool things that Python does under the hood, and just different patterns and methods and like CS overall that I think would be really cool presentations. Because overall, like developing security tools is something that we really need to do, and I think that this tries to help with that. So, any questions I can answer? Over there.
How does RIT fit into
No. No, I think we finished that like slide 4. Pretty much, you were done with CS1. What's up?
To give a little bit less of a meme answer on that, so how RITLib was structured was a way, so typing in Python hasn't been existent since 3.6, and even after that it hasn't really been well fleshed out until 3.7, which just came out over the summer. So in order to make programming slightly easier for freshmen and people taking CS1, the CS department created RITLib, which basically was their way of pushing strict typing into Python, and that's what RITLib does. It's a mess to program with, but that's what it does. It helps you try to find like type errors to make that more of a hand-holding exercise because it is CS1. But yeah, they in theory they could just use this now. But
Fun fact, they're not using RITLib anymore in CS1. They're replacing it with data classes, which is unique to
Ah,
2007.
wonderful. Thank you. That's
there we go. That's exactly, that makes sense. All right. Makes sense.
There's a bunch of things that I left out of the talk, like data classes, because it's hard to get to those. Cool. Thank you.
Okay.
That is all the time that we have for this week. The presentations have been put onto the workplace in the research group, so you can look at them again at your leisure. Have a good week.
Yay! You have a great week.